All right, friends, welcome back. This is Mr. Burrell again. For the last part of our Law of Signs lesson, we're going to talk about what's called the ambiguous case. This is an honors topic, but it addresses the fact that with some problems, with some of these triangle problems where we can use the law of signs to find a missing angle, there are two possible triangles. Let me explain. So, if you remember way back in your math experience, you talked about triangle congruency, and you're like, okay, there's all these different ways that you can prove that two triangles are congruent, but angle side side is not one of those methods because it spells a bad word. You might have been exposed to that in the past. Right now, I'm going to explain to you why. So, here on this little applet that I have pulled up, I have a triangle. I know this angle right here is 30 degrees. I know this side is 10. And I know this side is 6. So right now, that looks fine. That looks like a perfectly decent triangle. But notice something when I move this side. I haven't changed the side length, but if I move it over here, that triangle also exists. That's an actual other triangle with those same stats. This angle is 30 degrees. This side is 10. This side is 6. So it's possible that if I have this angle, this side, and this side, that I actually have two triangles. This triangle would have a smaller angle over here, and this triangle over here would have this obtuse angle right here. That's not always going to be the case. In this case, I was able to form two triangles. Let me shorten this side a little bit. If I shorten this side a little bit more, notice here if I had these stats, angle 30 degrees, this side is 10, this side is 3.8, I can't form a triangle with those stats. There's no way. What about if I make this triangle like, I don't know, 11.3? This side is 11.3. So I have this angle that's 30, this side is 10, this side is 11.3. So I have this triangle, and if I try to put it over here, I can't form another triangle on this by moving this side over that still has this angle being 30 degrees, this side of 10. It would be a completely different triangle. But when this side length was like in this general region, in the 6 region, I could form two triangles with those same stats. That is what is called the ambiguous case. So I'll explain why this presents us with kind of a dilemma when we start talking about the law of signs. So when we use the law of signs, say I was solving for this angle, whoops, let me go back. Say I was solving for this angle in this triangle. When I use the law of signs, and I go into my calculator and I do the inverse sine function in my calculator will only give me angles between 0 and 90 degrees when I talk about those inverse functions. So it'll give me this angle on this triangle. But notice that these two angles right here, this triangle right here, this little mini triangle that's formed in between these two sides, because these two sides are the same, I form an isosceles triangle. So these two angles are congruent, which means these two angles are supplementary, which means they add up to 180 degrees. So when I have this ambiguous case, this situation that could happen with these two triangles, I could potentially have this triangle where I have an acute angle, or I could potentially have this triangle where I have an obtuse angle. Let me show you an example. I don't think there's ones there. Well, you might need to check for ones like this on your homework, but there won't be a quiz on this section, but it's good and important to know. So, this problem says solve each triangle, round your answers to the nearest tenth. So it says measure of angle A is 36 degrees. Side C, so this side right here is 35 meters, and side A, I'm going to label side A over here as 22 meters. Because in my calculator, when I do this math, this is the triangle that it will envision. So we're going to start solving this, and as we solve it, I'll address some of the concerns that will be brought up because this is an ambiguous case. So I'm going to start by solving for angle C. So let's see, this is side A, this would be side B, this would be side C. So A, or 22, over the sine of 36 is going to be equal to 35 over the sine of C. I know that by the law of sines, because the opposite sides and angles, when I divide the side by the sine of their angle, all those ratios will be equal to each other. So sine of 36, that's 22 over 0.5878 is equal to 35 over the sine of c. And I'm kind of whizzing through this part because we've already done this. So 22 times the sine of c when I cross multiply is equal to 35 times 0.5877 or 0.5878, which is 20.57. I'm going to go ahead and divide by 22. I'll get sine of c is equal to 0.935. And then the inverse sine of 0.935, when I take my inverse trig functions to solve for the angles, I'm going to get c equals 69.23 degrees. 69.23 degrees. So this angle right here is 69.23 degrees. And before we just went about our business and we kept solving this triangle. So if this was the triangle and this was 36 degrees and this was 69.23 degrees, this angle right here would be 180 minus 36 minus 69.23, which would be 74.77. Okay. So now is the point in a problem like this where it'd be like, okay, is this an ambiguous case? Is it possible that I could actually have two triangles here? Well, in order to test that, we're going to pretend like, of course this picture isn't perfectly to scale, but we're going to pretend like we slide this side over here. So this is side A. This is my new triangle. This side is 22. This angle is going to be 180 minus 69.23. 180 minus 69.23. So this angle is 110.77 degrees because these two angles are supplementary angles. They add up to 180 degrees. Okay, so if this was an ambiguous case, then I should be able to have another angle here. This smaller angle would be 180 minus 110.77 minus 36, which in this case is 33.23 degrees. If I had taken 180 minus angle A minus angle C here and got some weird negative number, if I got a negative number, that would mean no, I can't have a triangle that has this angle and this angle because these two angles would already add up to more than 180 degrees. So the ambiguous case arises when I have angle, side, side, and when I find this angle by using the law of sines, and find this supplementary angle right here using my knowledge of supplementary angles, and then if that triangle actually exists, if I have three angles here that could add up to 180 degrees, then I have a situation where I have two potential triangles. So then if I wanted to keep solving, I could. I'm going to go ahead and I'm not going to completely finish solving this triangle, but I would have this triangle right here, and I'd have that triangle right there. Both of these angles would be 36 degrees. Both of these sides would be 35. Both of these sides would be 22. This angle would be 69.23 degrees. This angle would be 110.77 degrees. This angle would be 33.23 degrees. This angle would be 74.77 degrees. And then using the law of sines, I could finish solving for this side right here. Call it, I don't know, side B and side B prime or something. But that is a case that when we're talking about the law of sines, the ambiguous case where you can actually have two triangles that satisfy all the conditions that I give you, specifically these conditions right here. Again, I don't think I gave you any like that on your homework, but this is important and valuable and kind of cool, I think, to know. It's kind of interesting to see this angle side-side relationship with these triangles and how it relates to the law of sines. There's another triangle right here. I encourage you to pause this video and work On this triangle, this is another example of the ambiguous case where I have an angle side side. The ambiguous case will only pop up with an angle side side scenario. I encourage you to look at that problem. But I'm not going to go too much farther into that. That's the entirety of all of our law of sines things. Hopefully now you understand at least what the ambiguous case is and recognize that that really can happen with some of the triangles that we look at, and hopefully you feel pretty comfortable using the law of sines to find a missing side length and a missing angle. Please let me know if you have any questions. I hope you enjoyed that as much as I did.